We are going to start now chapter 10 of class 11th mathematics, straight lines, and this is lecture 1. So in our previous classes we have studied the chapters related to coordinate geometry. We have studied the formula related to the distance between the points. Then we have talked about the angle between the two lines and different coordinate systems. Now the first thing we have over here, it is the slope of a line. So the definition we have, it is the angle of inclination, or we are saying the inclination of a line, it is the angle theta which the part of the line above the x axis makes with the positive direction of the x axis. We are saying this is our x axis, we are talking about this line and we are talking about this angle. This angle is the angle theta. So this angle theta, it is called the inclination of this line. So the angle this line makes with the positive direction of x axis we are talking about, and this angle, it is measured in the anti-clockwise direction. If it is being measured in the clockwise direction, we put the minus or negative sign over there, and we are saying that this angle we have, it lies between 0 to 180 degree. So the inclination of a line parallel to the x axis or x axis itself, it is 0 degree. We are saying these are the x and y axis. We are talking about a line which is parallel to x axis, it may be this line, or we are talking about the x axis itself. This is x axis and this is the line parallel to the x axis. So all these lines, when we are talking about their angle of inclination, we have it is 0 degrees. Next we are talking about the line which is parallel to y axis. We are saying this is x axis, this is y axis. We are talking about a line which is parallel to y axis, and we are saying that this line, this makes an angle of 90 degree with the x axis. So angle of inclination of y axis or any line parallel to y axis, it is 90 degrees. Next we have is horizontal line. So we are saying any line parallel to the x axis or x axis itself is called a horizontal line. Then we have vertical line, any line parallel to y axis or y axis itself, it is called a vertical line. Next we have is oblique line. A line which is neither horizontal nor vertical is called an oblique line. We are saying, suppose we are talking about, this is the line we have, this is neither a vertical line nor a horizontal line, and this is the angle that we measure with the positive direction of x axis. We may have the line in this form, we are measuring the angle over here, this is the angle theta, this is the oblique line we have. Next we have is the definition of slope or gradient of a line. So we have seen this is the angle of inclination. The tan of this angle, tan theta, we are saying, we are writing it is m, it is called the slope of the line. This m, it is the slope of this line, it is tan of the angle of inclination. So based upon this, we have the following questions. First is, find the slope of a line whose inclination is 45 degree. So the slope of this line m, that will be tan 45 degree, that is equal to 1. Next we have it is 60 degree. We are saying m is equal to tan 60 degree, that is equal to square root of 3. Next we have is m is equal to tan 150 degree, and we are writing this value is equal to minus tan 30 degree. So that is equal to minus 1 by root 3. So these are the slopes of these lines. Next is the slope of the horizontal line is 0. We are saying the angle of inclination is 0. So tan of 0 is equal to 0. Next is slope of the vertical line is not defined, because we are saying it is tan 90 and tan 90 it is not defined. So we are saying the slope of the vertical line is not defined. Next is, what is the inclination of a line whose slope is 0, positive, negative and not defined. So we are saying, we are talking about the value of tan theta, we have it is 0. Then the value of theta we have it is 0. When we are saying value of tan theta is positive, then this thing means that the value of theta we have, it is acute, that it is lies in the first quadrant. Then the tan will be positive, because we know that the value of theta, it varies between 0 and 180 degree. So from 0 to 90 it is positive, then from 90 to 0 to, we are saying 0 is less than equal to theta is less than 90, it is positive. Then from 90 to 180 it is negative, and at 90 it is not defined. For this portion it is positive, for this portion it is negative. So this is the answer for this part. Next is slope of a line passing through two given points. So we are saying that if 2 points, one point is A, it is x1 y1, and second point is B, it is x2 y2, these are the 2 points given to us. Then the slope of the line passing through these 2 points, it is given by m is equal to y2 minus y1 over x2 minus x1. So we start the proof of this result. We are saying, suppose these are the x-axis and y-axis that we have, and these are the 2 points that are given. This is the point A and this is the another point B. Its coordinate, they are x2 y2, and the coordinates of this point, they are x1 y1. Now if we join these 2 points, we obtain a line over here, and suppose this line, it makes an angle of theta with the positive direction of x-axis. This is x-axis, this is y-axis, this is the point O. Now if we look at a triangle we are talking about, at this point A we have drawn a line parallel to x-axis, at this B we have drawn a perpendicular over here, and where these two they meet, we are saying this point it is N, and this angle we have, it is theta. Then what we obtain is that the value of tan theta we have, it is Bn over An, and Bn we can write, if we extend this point and we are saying this is up to m, then we are writing this is equal to Bm minus Mn divided by this value we have, it is, we draw the perpendicular over here and name this point as L, this length it is L m, and we can write this is equal to, now look at this point, this is y2, y2 means this complete height we have, this is y2 bm, and mn means we are talking about this point, so this height we are saying this is y1 divided by, we are talking about the length lm, we are talking about this length lm, so we are saying this complete length we have, it is x2, and this length we have, it is x1, and we are writing in place of lm, we are writing it is x2 minus x1. So we are writing this value tan theta, we know that this is equal to m, we are saying this is equal to y2 minus y1 over x2 minus x1, and this is the formula for the slope of this line that we have to prove. Next is find the slope of the line passing through the points minus 2, 3 and 8 comma minus 5. So the formula we have for this first case, we are saying the value of m we have, that is equal to minus 5 minus 3 divided by 8 plus 2. So the answer we obtain, that is equal to minus 8 by 10, that is equal to minus 4 by 5. Next, in this second case, we are saying the value of m we have, that is equal to minus 3 plus 3 divided by 6 minus 4, and the answer we obtain, that is equal to 0. So this thing basically gives us, if the slope is 0, it means we are saying that this line, it is parallel to x axis. Next, in this third case, we are saying the value of m we have, that is equal to 2 plus 1 divided by 3 minus 3, and this value we are saying this is not defined. So we are saying the value of theta that we have, it is equal to 90 degree. That is, this line is parallel to y axis. This line is parallel to y axis, and the slope is not defined in this case. Next is, if the slope of the line passing through the points 2, 5 and x, 3 is 2, find the value of x. So if we calculate the slope, we are saying it is 2. The value we have, it is 3 minus 5 over x minus 2. So we are writing this is equal to minus 2 over x minus 2. So this implies us that minus 2 over x minus 2 is equal to 2. This 2 gets cancelled. So x minus 2 we have, that is equal to minus 1. So this implies us that x is equal to 1. So we are obtaining over here that the value of x we have, it is equal to 1. Next is, find the value of x so that the inclination of line joining the point x, minus 3 and 2, 5 is 135 degrees. So we are saying the slope of this line we have, it is tan of 135 degree, and that is equal to 5 plus 3 divided by 2 minus x. Now the value of tan 135 degree, it is tan 180 minus 45, that is equal to minus 1. So the equation we are getting from this, it is 8 over 2 minus x is equal to minus 1. So this implies us x minus 2 is equal to 8, and this implies us x is equal to 10. So this value gives us x is equal to 10. Next is, find the angle between the x-axis and the line joining the points 3, minus 1 and 4, minus 2. So we are calculating the slope of this line, which is obtained by joining these 2 points. So the slope we have, it is m is equal to minus 2 minus minus 1 divided by 4 minus 3. So the value of m we obtain, that is equal to minus 1. This is the value of m that we have. Now we have to calculate the angle it makes with the x-axis. It means we are talking about, we have to calculate the value of theta, for which tan theta is equal to minus 1. And we are saying this is tan theta is equal to minus tan 45 degree. But we know that the value of theta we are having, it lies between 0 and 180. So we are writing, this implies us that tan theta is equal to tan of 180 minus 45, that is equal to tan of 135 degree. So this implies us that theta is equal to 135 degrees. This implies us that the value of theta that we have, it is equal to 135 degree. Next we have is slopes of parallel lines. So we are saying that two non-vertical lines are parallel if and only if their slopes are equal. So we are saying, so these are the two lines we are talking about. This is our x-axis, this is y-axis, and these are the two lines we are saying. This is one line, this is another line. This is line L1, this is L2. This makes an angle of theta 1 and this makes an angle of theta 2 with the x-axis. This is the point O that we have. Now it is being given that we are saying if these two lines, they are parallel. First we are considering, let L1 is parallel to L2. It means that these two angles that we have over here, this theta 1 and theta 2, these two lines, these are given to be parallel. So we are having theta 1 is equal to theta 2. So this implies us tan theta 1 will be equal to tan theta 2, and this implies us that slope of first line is equal to the slope of second line. This is equal to over here. And conversely, if we consider that there are two lines whose slope they are equal, we are saying it is being given, we are saying let m1 is equal to m2, then this thing means that tan of theta 1 is equal to tan of theta 2, and this thing implies us that theta 1 is equal to theta 2. This thing holds because we are saying theta 1 and theta 2, they belongs to 0 to pi. So we are saying L1 and L2, theta 1 is equal to theta 2 means both these angles are equal. It means both these lines, these are parallel to each other. So we have obtained that two vertical lines are parallel if and only if their slopes are equal. Next is slopes of perpendicular lines. So again we are considering there are two lines which are perpendicular to each other. These two lines, these are perpendicular to each other. We are talking about this is the line L1, this is the line L2, and both these lines, these are perpendicular to each other, means this angle is 90 degree. Then we have to prove that m1 into m2, the slope of these two lines, they are m1 m2, the product of m1 m2 it is equal to minus 1. So we are saying if this angle it is theta, then this angle we have it is 90 minus theta, and this angle we are saying this is the angle theta 2. This angle is theta 1, then this angle is theta 2, then this value we have it is 90 minus theta because this angle is given to be 90 degrees. So what we obtain from this is that slope of the line L1 it is m1 is equal to tan theta 1, and slope of the line L2 it is m2 that is equal to tan theta 2, and further we have is 90 minus theta 1 plus theta 2 that is equal to 180. So we obtain that theta 2 is equal to 90 plus theta 1. So tan theta 2 is equal to cot minus cot theta 1. So this thing implies us that tan theta 1 into tan theta 2 that is equal to minus 1. And what is tan theta 1 and tan theta 2? These are the values for m1 and m2. These are the values for m1 and m2. So we obtain m1 into m2 is equal to minus 1. So we are saying that the two non-vertical lines with slope m1 m2 are perpendicular if and only if m1 into m2 is equal to minus 1. Next, conversely we are considering, let there are these two lines are there and their slopes are m1 m2, and it is being given that m1 into m2 that is equal to minus 1. Now clearly we have the value of m1, we have it is tan theta 1, the angle it makes with the x-axis, this first line it is theta 1, and m2 is equal to tan theta 2, and we have tan theta 1 plus into, it is not plus, it is into, tan theta 2 is equal to minus 1. This implies us tan theta 1 is equal to minus cot theta 2. This implies us tan theta 1 is equal to tan of 90 plus theta 2, and this implies us that theta 1 and theta 2 differ by 90 degrees, and this implies us that L1 is perpendicular to L2. So this is the converse part that we have. So combining both these results, we obtain L1 L2 are perpendicular to each other if and only if m1 into m2 is equal to minus 1. Next is show that the line joining the points 2, minus 3, minus 5, 1 are parallel to the line joining these two points. So we calculate the slope for both these lines. For this first line we have m1, slope of this line, it is equal to 1 minus minus 3 divided by minus 5 minus 2. Answer we obtain it is minus 4 by 7. And slope for this second line that we have, it is m2, that is equal to 3 minus minus 1 divided by 0 minus 7. So answer we obtain it is minus 4 by 7. So what we have is m1 is equal to m2. So this implies us that line 1 is parallel to line 2. If this is line 1, this is line 2. So line 1 is parallel to line 2. Next is show that the line joining the points this, say this line it is L1, and this second line this is L2. We have to prove that both these lines, these are perpendicular to each other. So for the line L1, we are saying slope m1 that is equal to 5 minus minus 5 divided by minus 2 minus 2. The answer we obtain that is equal to plus 10 by minus 4, that is equal to minus 5 by 2. And for the second line, for this line L2, the slope m2 we have it is 1 minus 3 over 1 minus 6. The answer we have it is minus 2 by minus 5, it is equal to 2 by 5. So from both these results what we obtain is that m1 into m2 that is equal to minus 5 by 2 into 5 by 2 by 5, it is plus 2 by 5. So the answer we are getting it is minus 1. So we are writing m1 into m2 is equal to minus 1, and this thing implies us that the line L1 is perpendicular to line L2. So both these lines, these are perpendicular to each other. Next is, if the line through the point minus 2, 6 and 4, 8 is perpendicular to the line through the points 8, 12 and x24. So suppose this first line we are writing it is L1, this second line we are writing it is L2. So the slope of the first line m1 that is equal to 8 minus 6 over 4 plus 2. So the answer we obtain it is 1 by 3. m2 we have it is equal to 24 minus 12 over x minus 8. Answer we get it is 12 over x minus 8. Now it is being given that both these lines are perpendicular. It means 1 by 3 into 12 by x minus 8, that is equal to minus 1. m1 into m2. m1 into m2 is equal to minus 1. So this implies us this. So this implies us that the value of minus x plus 8 is equal to 4, and this gives us x is equal to 4. So required value of x is 4. Next is, without using Pythagoras theorem, show that these 3 points, when they are being joined, are the vertices of a right angled triangle. So we are saying, if we calculate, if we name these points, say this is the point A, this is the point B. A is 4, 4, B is 3, 5 and C point it is minus 1, minus 1. If we calculate the slope of line AB, we are talking about these 2 points. The slope of this line will be given by 5 minus 4 over 3 minus 4, that is equal to minus 1. If we calculate the slope of the line AC, we are calculating the slope of the line AC. Answer we have that is equal to, we are saying this is slope of AB, this is slope of AC. We are writing it is minus 1 minus 4 divided by minus 1 minus 4. The answer we obtain it is 1. So what this implies us? Suppose we are writing this is m1, this is m2. So we obtain that m1 into m2 is equal to minus 1. So what we get is that the line AB is perpendicular to the line AC. It means this angle at A, its measure is 90 degree. Further, if we calculate the angle between say AB and BC, then the slope of the line AB it is minus 1, we have already calculated. If we calculate the slope of the line BC, the answer we have it is minus 1 minus 5 over minus 1 minus 3. We get it is minus 6 by minus 4. So it is 3 by 2. Clearly, BC is neither parallel to AB nor BC is perpendicular to AB. So what we obtain is that this line BC is neither parallel to AB nor perpendicular to AB. So it means that these 3 points, they form a triangle, and that triangle is a right angled triangle, right angled at 90 degree. Why we have checked this thing? Otherwise we have just proved that these 2 lines, they are at 90 degree angle. Further, we have proved that this AB and BC, these 2 lines we have, these 2 lines we are saying these are neither parallel nor perpendicular. So that is why we have obtained that these 3 points ABC, they form a triangle and it is a right angled triangle. Next is using slopes show that the points, these 3 points are collinear. So we are naming these points as A, B and C. Now if we calculate the slope of the line AB, the slope of the line AB, that is equal to minus 1 over 1 minus 5, the answer we obtain it is 1 by 2. And when we are calculating the slope of the line BC, answer we have it is 4 minus 1 divided by 11 minus 1. The value we obtain it is 5 by 10 is equal to 1 by 2. Now clearly we have the slope of the line AB, that is equal to slope of the line BC, and this implies us that AB is parallel to BC, but this point B is common between both these. We are saying we have one line AB, we have another line BC where this point B is common between both these lines. It means that these 3 points, they must be collinear, they must be in the straight line. Next is find the value of x for which these 3 points are collinear. So again we name these points as A, B, C. Now if we calculate the slope of AB, the answer we have it is 1 minus 1 divided by 2 minus x, that is equal to 5 minus 1 divided by 4 minus 2. Now on solving this, we are saying this implies us 2 over 2 minus x is equal to 2, and this implies us x is equal to 1. When you solve this, you will obtain x is equal to 1. So we are saying that if these 3 points they are collinear, then the value of x we have it is equal to 1. Next is if these 3 points lie on a line, we have to show that this result holds. So again, suppose these points we are naming, this is A, B and C. So the slope of the line AB, we are saying that should be equal to slope of the line BC. So we are writing B over A minus H, that is equal to K minus B over 0 minus A, and this thing implies us that AB is equal to A minus H, it is minus A over here. So this term will become B minus K. So this implies us that AK plus HB is equal to HK, and this implies us that A over H plus B over K, that is equal to 1. This implies us that A over H plus B over K is equal to 1. Next is using the slopes show that the vertices, these are the 4 vertices, these are vertices of a parallelogram. So we name these vertices as A, B, C and D. We have marked these points over here. This is A, B, C and D. Now if we calculate the slope of all these lines, the slope of this line AB, it is 0 plus 1 over 4 plus 2. We get it is 1 by 6. Slope of this line when we are saying, it is 3 minus 2 over 3 plus 3. The answer we obtain it is 1 by 6. It means both these lines, both the slopes M1 and M2, they are equal. So we are saying both these lines, these are parallel to each other. Next, if we calculate the slope of this line, it is 0 minus 3 over 4 minus 3. The answer we have it is equal to minus 3. And slope of this line when we are calculating, it is minus 1 minus 2 divided by minus 2 plus 3. The answer we have it is minus 3. So we are saying the slope of both these lines, these are equal. It means again both these lines, these are parallel to each other. So what we obtain is that AB is parallel to CD and BC is parallel to AD. Opposite sides they are parallel. So this implies us that ABCD is a parallelogram. Now next we have is, these are the 4 points A, B, C and D given are vertices of a quadrilateral ABCD. Now P, Q, R, S are the midpoints of A, B, B, C, C, D and D, A. Then using the slopes we have to prove that P, Q, R, S, it is a parallelogram. So we are talking about, these are the 4 points. This is A, B, C and D. And we have the midpoints corresponding to these points. P, Q, R, S, these are the midpoints. So this point P, if we calculate the coordinates of this point, it is minus 4 plus 2 by 2 divided by 2 plus 6 by 2. The answer we obtain, that is equal to minus 1 comma 4. Then we are saying the coordinates of the point Q, it is 2 plus 8 by 2 and 6 plus 5 by 2. The answer we obtain, it is 5 comma 11 by 2. Similarly for this point R, the coordinates we have, it is 17 by 2 comma minus 1, and for this point S, the coordinates we have, it is 5 by 2 comma minus 5 by 2. Next, if we calculate the slope of the line PQ, we are talking about this line PQ, and we calculate the slope of this line, we are saying slope of PQ, that is equal to 11 by 2 minus 4 divided by 5 plus 1. The answer we obtain, it is 3 by 12 is equal to 1 by 4. When we are talking about the slope of the line, this RS, we are talking about the slope of the line RS. The slope we have, it is, this is slope of line RS. We will obtain the result, that is the slope of this line, it is again 1 by 4. We are saying the slope of the line RS is equal to 1 by 4. So what this implies is that PQ is parallel to RS. Similarly, if we calculate the slope of the line, say this line, we are saying it is slope of PS, that is equal to 5 by 2 minus 4 divided by 5 by 2 plus 1. The answer we obtain, it is minus 13 by 2 into 2 by 7, that is equal to minus 13 by 7. And we are saying this is equal to the slope of the line, this is equal to slope of the line QR. So what we obtain from all these results is that slope of PQ is equal to slope of SR. So PQ is parallel to SR. Slope of QR is equal to slope of PS. So we obtain QR is parallel to PS. So combining both these results, we are saying that the opposite sides of this parallelogram, they are parallel. So we obtain that of this quadrilateral are parallel. So PQRS is a parallelogram. Now next is the angle between two non-vertical and non-perpendicular lines. Why non-vertical? Vertical line means we are saying this is the vertical line. Why we are saying non-vertical? Because in this case the angle over here, it is 90 degree and the slope of this line, it is not defined. We are talking about two lines. First condition, we are saying that both these lines, these are non-vertical, and second is that these two lines, they are non-perpendicular. Then we are talking about this formula. So suppose we are saying these are the two lines, one is the line L1 and second is the line L2. This is the line L1 and this is the line L2 that we have, and these two lines, these are making an angle. Over here it is making an angle alpha 1 and this is making an angle of alpha 2. L2 is making an angle of alpha 2 with the x-axis. So what we obtain from this is, if this angle is alpha 2, then clearly we have this angle is 180 minus alpha 2, and this angle, if the angle between these two lines, it is theta, then this angle we have, it is theta. So what we obtain from this is that theta plus alpha 1 plus 180 minus alpha 2, that is equal to 180 degree. these three angles we are talking about, this is the angle theta, this is alpha 1, this is 180 minus alpha 2. The sum of all these angles, it is 180 degree. So this implies us that the value of theta that we have, that is equal to alpha 2 minus alpha 1, that is angle between these two lines, it is alpha 2 minus alpha 1. Now if we write tan theta, we have it is tan of alpha 2 minus alpha 1. This is equal to tan of alpha 2 minus tan of alpha 1 divided by 1 plus tan of alpha 1 into tan of alpha 2. So what this thing gives us? What is tan of alpha 2? It is, we are saying tan of theta, that is equal to m2, this is slope of the line L2, minus slope of the line L1 divided by 1 plus m1 m2. So this gives us the angle between the two lines, and the condition that we have over here, it is that 1 plus m1 m2 should not be equal to 0, that is m1 m2 should not be equal to minus 1. This value should not be equal to minus 1, and this is why we have taken the condition that these are the two non-parallel lines. Now let us look at the fact that how we are calculating this angle. We are saying we are having, these are the two lines we are talking about. So the angle between the two lines when we are talking about, we are saying this is the angle theta and this is the angle 180 minus theta. So when we are talking about tan of 180 minus theta, the answer we have it is minus tan theta, and we have seen that the value of this term minus tan theta we have it is minus of m2 minus m1 divided by 1 plus m1 m2. So we are saying that the tangent of the angle between given lines, we are saying tangent of the angle between given lines, it is given by plus minus m2 minus m1 over 1 plus m1 m2. Now we are having these two angles, one is this theta and one is this 180 minus theta. So one of these angles will be acute, other will be obtuse angle, because they are not perpendicular lines. So we are saying one of them will be acute. So we are saying that alpha be the acute angle, and that is equal to minimum of theta and 180 minus theta. And if this alpha is acute angle, it means that the value of tan alpha that we have, it is mod of m2 minus m1 over 1 plus m1 m2. It is mod of this value. Tan alpha is equal to mod of this value. So this is the formula for the angle, the acute angle we are saying between the two non-vertical and non-perpendicular lines. Next is find the angle between the lines whose slopes are 1 by 2 and 3. So we are saying the slope of this first line, it is m1 is equal to 1 by 2. Slope of the second line, it is m2 is equal to 3. Then we are having tan theta, that is equal to mod of m2 minus m1 divided by 1 plus m1 m2, and this is equal to mod of 3 minus 1 by 2 divided by 1 plus 3 into 1 by 2. This is equal to 5 by 2 divided by 5 by 2 mod, that is equal to 1. So we are saying the value of tan theta we have is equal to 1. So this implies us that the acute angle between two lines, it is 45 degrees. Next is A is equal to, the point A is given, it is minus 2 comma 1. This point it is minus 2 comma 1. B is 2 comma 3, and this point C it is minus 2 comma 4. And these are the vertices of a triangle ABC. We have to show that tan B is equal to 2 by 3. We have to show that tan B is equal to 2 by 3. It means we have to calculate the angle between the line AB and the line BC. So if we calculate the slope of this line AB, the answer we have, it is 3 minus 1 over 2 plus 2, that is equal to 1 by 2. If we calculate the angle between these two lines, it is minus 4 minus 3 divided by minus 2 minus 2. The answer we have, it is 7 by 4. Now the angle between these two lines, it is given by tan B is equal to 7 by 4 minus 1 by 2 divided by 1 plus 7 by 4 into 1 by 2. So we obtain that tan B is equal to 2 by 3. We obtain that the value of tan B is equal to 2 by 3. Next we have is, if the angle between two lines is pi by 4 and the slope of one of the lines is 1 by 2, find the slope of the other line. Now the value of theta is given to be pi by 4. Value of m1 is given to be 1 by 2. We have to calculate the value of m2. So by using the formula for angle between lines, we obtain that mod of m2 minus 1 by 2 divided by 1 plus m2 by 2, that is equal to tan pi by 4, that is equal to 1. Now we have two values. One is m2 minus 1 by 2 over 1 plus m2 by 2, it is equal to 1, or we are saying m2 minus 1 by 2 divided by 1 plus m2 by 2, that is equal to minus 1. So if we solve both these values, we obtain that 2m2 minus 1 is equal to 2 plus m2, or 2m2 minus 1 is equal to minus 2 minus m2, and this thing implies us that the value of m2 we have, it is equal to 3, or value of m2 we have, that is equal to minus 1 by 3. So we obtain that the slope of the lines, the slope of this other line, it may be 3 or it may be minus 1 by 3.